Hello and good morning, everyone. Welcome to this sunny, bright, lovely morning, certainly here in Sheffield. I hope it is where you are too, not too warm. We've been meeting earlier this morning and I think everyone's melting, so do bear with us over the next hour. A lot to jam into an hour, so we'll be as slick as we possibly can. We are expecting upwards of 50 to 60 people this morning. I think we've got nearly 40 online so far. We'll just give it a couple of seconds for others to join. But for those of you that don't know me, I'm Dave Dalton. For my sins, I head out British Glass, the trade federation responsible for the launch this morning. And what we're going to do is, through this next hour, walk you through our glass sector net zero strategy. So for those of you that are familiar, British Glass is both a representative body supporting the glass industry here in the UK and its main partner in research and development through our technical wing GTS, delivering solutions to the technical needs of the sector. Today we launch our latest stride forward from the 2015 sector carbon reduction roadmap, which I think many of you will be familiar with. That roadmap was set on around the government announcements for an 80% reduction in CO2 production, and our plans to do that were backed by the entire industry and the associated supply chain. Since then, the government has moved forward with a more all-embracing net zero strategy, and we've been working very closely to deliver that too. So today is our launch event to help you understand the journey that we've just embarked upon, guiding our industry and manufacturing supply chain towards this target of net zero. For those of you that have been in the industry anywhere near as long as me, and unfortunately that is 40 years as of last year, the industry historically has had a little bit of a dirty smokestack reputation, but that's not the case anymore. Glass is now a material of the future, perfectly positioned to lead in the circular economy, infinitely recyclable, food and drug safe, aesthetically beautiful, and boundless in its applications and potential to solve society's future needs. We are setting about the journey to make sure that is delivered. Since we recognise this opportunity, we're working with all our major parties involved in glass production, supply chain utilisation, post-consumer recovery, to shape policy, to employ technology, and to develop solutions that demonstrate our role in the world of tomorrow. So Glass has a journey to embark upon. We've created a partnership, worked closely with successive governments, and today we're proud to share our plans to take glass through this journey to truly demonstrating net carbon zero as the most sustainable material in all facets of its use. We've already demonstrated progress, reducing our energy requirements by over 50% in my own working lifetime. But over 1.5 million tonnes of carbon dioxide has still been generated in the UK glassmaking sector alone. We still have much to do to deliver this net zero target. And so we've worked closely with all stakeholders to agree a coordinated set of actions to ensure we get there in the government's timeframe well before 2050. Today, we'll share with you some of the details of just how we intend to do it. We engender all of your support to help us achieve it, and critically, whilst remaining competitive in the marketplace, employing thousands of skilled people to support the economy and continuing to provide the material choice commensurate with society's future needs. We'll need policy makers to listen and to assist, and will require a mechanism significantly more robust than a simple deposit return scheme in the container glass sector to ensure we capture virtually every piece of glass we place on the market. We need brand and retail to be open to accommodating the highest recycled content, and to educate the public to ensure that behaviour is in line with our need to return materials in the quality and quantity required. We'll need architects and engineers to better understand glass and employ it more fully. We'll need Big Pharma to understand the environmental needs alongside health and safety requirements and standards to recover vaccine vials and so much more if we're going to get the glass sector to this position of net zero. One of our main elements to success will be the ability to follow the future energy strategies as yet not committed to by any administration. All governments have looked to forward new energy policies. We've looked at different hydrogen, we've looked at biofuels, we've looked at all manner of different green electricity sources, and none of these have yet been committed to. And industry is heavily committed to energy consumption. Will need to understand the nature of that movement and work with it. So will green electricity become the norm? Will CCUS be readily accessible? Will there be a hydrogen economy? Will biofuels be abundant and affordable? All of these questions remain open, and we have to work alongside answering those questions to make sure our industry continues to be viable and to manage the transition from one fuel source to another. And the presentations today will touch upon some of the difficulties in those areas. There's a lot to consider and a lot more to actually manage and deliver. And none of the above starts to even contemplate the technical difficulties in physically switching fuel sources to make any or all of these potential solutions viable. Today, we'll walk you through how we intend to deal with some of these issues and how you can help us understand the tasks at hand and the ask that we put to you. Beyond what we in the glass making sector can do through our manufacturing process, glass itself is already a fantastic material that could easily lay claim to be net zero from the perspective of the impact of the products we already place on the market. In crude terms, what I'm saying is the carbon savings achieved across the useful life of glass made and put into highly efficient glazing systems alone already saves more than 10 times the carbon invested in the manufacture of all types of glass here in the UK, and a similar position exists right across Europe. Insulation fibre used in wind turbine blades adds even further to this argument. And then when we consider container glass extending the useful life of perishable foodstuffs and beverages, preventing the even more disastrous escape of greenhouse gases like methane from rotting foods, further compound this argument. So yes, glass could rest on its laurels and argue to be in a position to have to do nothing, but far from it. We intend to remove carbon at source, to be an industry removing carbon from its actual manufacture. And today we will walk you through the key steps and all the companies that have signed up to help us achieve this exciting challenge. Please help us on this journey. I'll not ramble on any longer. I shall pass over to our speakers today. We have on the agenda Paul Piercy, who is our policy and political lead in this arena. He will explain some of the barriers to decarbonisation and some of the policy changes needed. And then our last presenter will be Mark Pudner, our technical lead, who will look at some of the specific issues that we have to deal with. We intend to be through this by around 10:45, leaving about 15 minutes at the end to cover questions. We hope that all of you received this link from yesterday when we launched our strategy. The link should be available to everyone, and if you have had a chance to look at it already, you may have some questions. I do implore you to read through it at your own leisure and understand and derive questions from it, and then do get back to us. This is a process where we need your engagement, we need to collaborate, we need the policymakers and the whole supply chain to be working in concert with us to achieve this goal. It's not going to be easy, but it is something that we are as an industry completely signed up to, and we are in a position to believe we can deliver it. Some options yet to be decided, and through the next presentation we'll put some of those options to you so you can understand the position that we're in and the decisions that we need to take. So without further ado, I shall pass over to Paul Piercy, who will talk you through the key challenges and barriers to decarbonising and our policy recommendations. Thank you, Paul.
Thanks very much, Dave, and good morning, everybody. I hope everyone's okay and keeping cool in this lovely weather. So I'm just going to go through some of the key challenges and barriers to decarbonisation and also some of the policy recommendations. I'm not going to cover absolutely everything that's in the report, but just the main ones. So next slide, please. So I think really the main one that's that Dave mentioned in his introduction is the financial viability of alternative fuels. There's a graph on there that is just a representation of electricity prices in the UK. Obviously, one of the main options for us is electrification. And as you can see, the dotted line is the EU medium price of electricity, and the red line is what the UK is currently paying at the moment. And it's steadily increasing. So, this is one area that really needs to be addressed. If the glass industry is to decarbonise, we need access to competitively priced low carbon fuels. You've probably seen in the report as well the terminology of carbon leakage. The glass industry is at risk of carbon leakage. And what that basically means is the situation that may occur if, for reasons of cost related to climate policies, businesses were to transfer production to other countries with laxer emission constraints, and this could to actually lead to more carbon emissions in general. So we need to be very careful of that. And the glass industry, all three sectors, fibre, container and flat, are all at risk of carbon leakage and are on the EU's list of at risk of carbon leakage. So we need to be very careful that we don't just offshore our emissions. Yes, and I mean, just also onto the gas side. At the moment, gas is reasonably competitively priced within Europe, but there is a move from the government recently, the green gas levy that's been announced and things like that, looking at moving some of the policy costs from electricity over to gas. But when the glass industry doesn't have a financially viable solution to change to, just putting more tax on gas doesn't help in the short term. We need to address the problems of the high electricity prices within the UK before we start adding costs onto industrial users. We don't have a financially viable alternative, whereas domestic householders do have an alternative. Heat pumps, although they are slightly more expensive, they do have an option to move over to electric heating, whereas the industry don't. Next slide, please. So I'm not going to go through all the policy recommendations here, but I'll pick a few out. And some of these, as you've probably seen if you've read the report, are actually policies that were recommended by the CCC in their 6 carbon budget, which was released in, I think it was the turn of the year. So establish a funding mechanism to support operational as well as capital costs associated with switching to low carbon fuels such as hydrogen, biofuels and electricity. So looking at the operational costs, some of the operational costs for going to electricity are around 3 times higher than what they are on natural gas. For electric and biofuels, we think around 3 times the cost. And for hydrogen, sort of a bit of an unknown at the moment, but it's probably going to be around the same, if not slightly higher. And reforming electricity prices to reflect the much lower cost of supplying this low carbon electricity in the mid-2020s and beyond. So I know the government is starting to look at this, and we're expecting a consultation looking at the fairness of how electricity costs are distributed. And then, the one that I sort of mentioned in the slide before, which is the design of policies to reduce UK manufacturing emissions, must ensure that it does not damage the competitiveness of manufacturing and drive the manufacturing overseas. So that's going back to the sort of carbon leakage point. So, electricity is one of the main barriers to electrification. And if we were to get more competitive electricity prices, we could increase the amount of electric boost in the furnaces, and also look at a further rollout of Oxyfuel, which is basically mark or cover it, but it's an efficiency. You basically put oxygen into the furnace and you get about a 10-15% reduction in that. So, but that requires electricity to make the oxygen. Yeah, so we really need funding that covers the capex and the opex costs until the fuel switching prices become competitive, and funding levels as well within the UK are way behind that the EU have. So although there is some funding out there, it's just not at the same levels that it is within the EU. So we need to ensure that within reason that we have a similar amount of funding to get our hands on to decarbonise. Okay, next slide, please. And then infrastructure is also another key challenge. So in terms of electricity capacity upgrades, we have done some work on this with Glass Futures as part of the fuel switching report, and some of the sites, just for the capacity upgrade, this isn't the cost of actually electricity, could cost up to £12 million per site and take between 3 and 7 years to actually come online, which if we don't work on this up front, that is going to become a potential barrier to us decarbonising. In terms of hydrogen, we only have a potential of 4 sites near the existing clusters. So, we are sort of very concerned about this, that this may end up with a competitive advantage for those sites that have access to hydrogen earlier than some of the sites that aren't in those clusters. And, we are expressing those concerns with government. In terms of biofuels, we still have some concerns over the availability and sustainability. One concern is that other sectors you may hear in the news, such as aviation and shipping, seem to be considering biofuels for those areas. So it is a concern from the industry that we may not have that availability in the future to use biofuels to any great extent. And so it's something that we need to keep on the radar and keep looking at, and hopefully when the government announce their biofuel strategy, we may get a bit more information on sort of where they expect the biofuels to be used. Next slide, please. So in terms of policy recommendations, we need to upgrade and future-proof electricity capacity and networks to enable the electrification of glass manufacturing. When we have spoke to some of the DNOs where our members are, there seems to be a lot of focus about electrification of vehicles and electrification of homes and domestic properties, but very little on industry and what is required in the future for industry. So I think it's one thing that we need to really work with Ofgem and the DNOs and government to ensure that we're aware of when potentially we may look to electrify if the costs allow us, and making sure that capacity is going to be available when required. Support for upgrading of the site electricity connections for electrification of glass. As I mentioned in the previous slide, we are looking at up to 12 million for some of the sites that would require additional capacity to go to full electrification, and ensure that the biomass strategy reviews and addresses any concerns over availability and sustainability of biofuels, and ensure that the hydrogen infrastructure allows the non-cluster connections by 2035 or very close to that date, to ensure that we can sort of push through. Next slide, please. And in terms of technical feasibility and large-scale demonstration, so some glass sites have limited space on site for additional infrastructure. So Dave mentioned it at the beginning, but CCUS Basically for CCUS, you need basically a chemical plant on the side of the glass factory. And some glass factories, don't have that space requirements on site. And the same for biofuels. If you want to be running biofuels, you do need, large tanks on site and enough storage on site to be able to store the biofuels, etc. And obviously, some of those sites don't have the footprint on site to be able to use that. So it does limit them in terms of what options they can take. Most of the technology is unproven on a larger scale, and further development is required. And Mark will sort of go through, what is readily available and what needs further development. But it's one area that to de-risk these technologies, we need to be able to test these on a larger scale and demonstrate that they work for glass manufacturers to have the confidence in moving to those fuels. Next slide, please. So in terms of policy recommendations around these, so the government have got some funding out there for deep decarbonisation innovation projects, but we just feel that it's probably not enough at the moment. And I know some of the members have put forward some funding applications, for some decarbonisation projects, which has been successful with. But we feel going forward, we need longer term funding. I think these funding streams only last for, I can't remember, but fairly short amount of time, whereas this needs to be a constant funding stream to help the industry decarbonise. And establish funding for large-scale industrial demonstration projects would cover additional OPEX as well as CAPEX. The CAPEX costs are one thing, but it's, as we sort of talked about in the previous slide, in terms of the operating costs, could be up to 3 times higher. And on a glass factory, basically the cost of a glass factory, roughly about a third of the costs is energy costs. So if you imagine 3 times the energy costs that they're currently paying, they become financially unviable to run their business, because they're already running at about 30% of their costs are energy costs. So we can't, it's not like the energy costs are like 1% of their operating costs. They're significant amounts. So therefore we do need help with those operating costs, especially if they're uncompetitive, which they are currently. Next slide, please. And then in terms of availability of colour, again, Dave's touched on this in his introduction, but colour, if roughly speaking, a glass factory, 80% of their direct emissions are down to combustion and about 20% down to raw materials. So even if we were to move to hydrogen and CCUS or full electric, we're still going to have 20% of our, or 25% of our carbon emissions that are still down to raw materials. And so the way to combat this is by recycling glass back into the melting process, which reduces the amount of carbon and the raw materials that require. So some of the key challenges and barriers that we've got around availability of colour is obviously the deposit return scheme. We think that this could have a detrimental impact on the quantity and quality of glass available to remelt back into the containers, and unambitious glass recycling targets by the government. So we are doing some work with government on this, but under the current producer responsibilities system, producers must recycle 81% of glass, but only 72% of that actually goes back into remelt. The rest of it is going into aggregates, which we see as sort of lost potential, really, because that's downcycling. If we put it back into glass, it reduces CO2, for the producers, etc., and is better for the climate. There also is a colour imbalance within the UK. So we export a lot of flint glass, which results in a limited supply of flint colour within the UK. And there also is an oversupply of green colour within the UK. So We are looking at trying to address that, and some of you may have been on some of the meetings that Phil's been running in terms of closing the glass loop, etc. So we are doing some work on this. And then flat glass recycling. Currently, only small amounts of flat glass are recycled, and most of this is pre-consumer. So that's basically when it goes to the glazers and they cut out, and then it's the offcuts that go back to remelt. So once it actually gets into someone's house or building, the amount of glass that's recycled from that stage of the process is very limited. And the majority of flat glass, believe it or not, is either goes to aggregate or landfill, you know, which is really disappointing, and is a loss. And you know, we could reduce CO2 and become more energy efficient if we get that back into remelt. And also the flat glass can also be used if the quality isn't quite good enough to go back into windows. It can actually be used to go back into container glass as well. And like we said before, there is a colour imbalance. We don't have much flint. If we can get that back and put that into container, we can use that as the flint. Okay, next slide. So again, there's quite a lot of policy recommendations. I'm not going to read through all of them, but the main sort of spin on this is from container. The government is looking at consistent collection at the moment for UK glass recycling. We want new reformed extended producer responsibility for packaging. New remelt targets for obligated producers, so increasing those so we get more of that glass coming back into remelt. And obligations on businesses across the UK to recycle glass. And the big one really is exclude glass from the upcoming UK-wide deposit return scheme. And the reason for that is that, you know, we will be, as part of the DRS, we worry that there's going to be two separate waste streams for glass. So there's going to be one which will be going back to the reverse vending machines, and then all your jars and condiment bottles, etc., will be going in your bin outside, and this will be confusing for consumers. And also the reverse vending machines will actually crush the glass, and if they crush the glass too small, then it can't be colour separated, and therefore if it can't be colour separated, then it can't go back to remelt, and therefore we end up actually in a worse position than we probably are now. So we have raised these concerns. As you're probably aware, Scotland are going ahead with a DRS, and the UK are currently sort of considering their options. Further information on why we're sort of against DRS is available on the website, so I'll ask you to have a look at that if that's an area of interest. And then flat glass, we would like to see recycling of flat glass written into public sector contracts in terms of government buildings and schools, etc., as a starting point to sort of, to really sort of help, promote flat glass recycling. Landfill tax that incentivise flat glass recycling. So if you actually send flat glass or any glass to landfill currently, you pay a lower rate of landfill tax. It's currently about £6 a tonne, whereas the normal landfill tax rate is around 96. So we'd like to see the government look at a landfill tax that incentivise flat glass recycling. And then raising awareness of the circular options with the construction industry. So we are on sort of the Green Construction Board, etc. And so we're sort of trying to promote that as well. Next slide. I think that's it for me, is it? Yeah. So over to Mark.
Okay, thanks, Paul. Yes, so as part of our net zero strategy, we decided that we needed to model the different options just to see that the sector could actually get to net zero by 2050. So we've developed a model which is basically a large spreadsheet which looks at the different sectors. So we cover the flat container and continuous filament fibre sectors, which are members of British Glass. And for each of those sectors, we looked at implementation of different decarbonisation technologies from 2019 through to 2050. And we also, for flattened container, we also looked at cullet availability and use. So what the outputs of the model are a summary of all site fuel use, including electricity. So the model just looks at site fuel use, so furnace and non-furnace, and it also calculates the CO2 emissions from process, so from raw materials, combustion, and electricity use as well. There's quite a few assumptions within the model, but the main ones are that new furnace technologies are only applied at a planned rebuild, so we're not rebuilding any furnaces before the end of their life. That's one thing we wanted to make sure in the model, that we could demonstrate getting to net zero without having to scrap furnaces early. We also assume that industry has got access to competitively priced fuels, as Paul said. There's adequate funding available for research and large-scale industrial demonstration, give manufacturers confidence that the technologies will work, and the rest of the enabling policies within the strategy are put into place. We also use the electricity grid factors from National Grid future energy scenarios, and that assumes that the grid will be going carbon negative by the sort of early 2030s as well. Next slide, please. Okay, so just going to run through the technologies now that we've included within the model. As Paul said, there's a lot more detail on these within the main report, including a list of what we see as the current barriers to implementation. So we assume that we're still going to have some energy efficiency improvements within the process. We know that the current air fuel regenerative furnaces that the majority of manufacturers use are close to what's technically possible at the moment, but we do see some slight improvements due to improved sensor technology and implementation of intelligent control systems for those furnaces. I think the main opportunities that we're going to see for improvements are in electricity consumption through replacement of LED lighting, upgrading compressed air systems, and fitting variable speed motors, variable speed drives to motors on site. We're aware that some sites have already done this, but there's opportunities on others to implement those changes. In terms of waste heat recovery, there's a number of examples of waste heat recovery systems in the UK, but there's quite a large opportunity to install these on other sites. Within the model, we've assumed that it's likely that these are going to be ORC systems to generate electricity, but they could also be used for generating compressed air for use on a container glass site. I think the main barrier for waste heat recovery is payback. Even with grant funding, it doesn't quite pay back in time, but there's also a lot of uncertainty over what the future furnace energy technologies are going to be. So, you know, it may pay back with a standard air fuel furnace, given the waste heats and waste gas volumes now. But if you were to switch to a furnace using a larger proportion of electricity or all electric furnace later on, then the waste heat recovery unit wouldn't be much use. There's other opportunities for use of waste heat as well. So preheating raw materials to return that energy back into the process. And there's also some more sort of novel uses such as OptiMelt or HeatOx, and there's links to some more further details of those in the report. Next slide, please. Short term, we see that there will be some installation of Oxyfuel furnaces. These are probably going to be within the container glass industry, we think, and that's probably due to the potential to save 10 to 15% energy, but also possibly due to NOx emissions as well. As you're not using combustion air, you eliminate the source of nitrogen for NOx generation there. Barrier to this currently is the high electricity costs for generating the oxygen. And until recently, In terms of CO2, they weren't too much better because you sort of generate CO2 emissions through the electricity that you use to produce the oxygen. But as the grid carbon factors coming down rapidly, this technology is going to be better off in terms of CO2 emissions. For liquid biofuels, we've assumed that these are going to be used in the short term. There's a wide range of possibilities for what biofuels we could use, but currently, biodiesel seems the only one at the moment. This is fairly similar to the diesel that was used in the furnaces previously. Problem being with it that it's even more expensive than electricity to use at the moment. So there are projects looking at lower grade wastes that require sort of minimum processing, so they're at a lower cost. So they may be available at a later stage. But we see an issue with biofuels in terms of sustainability, but also long-term supply as we get competition from other sectors for them, potentially other countries incentivizing them, and potentially government policies working against biofuels due to concerns over sustainability. But it could be an attractive option to sites, particularly those that already have the storage tanks and equipment to handle liquid fuel from when they had heavy fuel oil or diesel as a backup fuel. Increased cullet, we'll talk about that a bit later, but using cullet does save energy as well. So 10% addition of cullet will achieve approximately a 2.5% saving in furnace energy as well. And there's the whole chapter in the strategy which deals with circular economy and cullet use. Next slide, please. So longer term options, these are really the sort of step change options that we are needed to get the sector to net zero. All electric melting, that's an established technology, and I think it must be considered as the sort of most environmentally friendly option if you're combining that with electricity generated from renewables. You not only eliminate CO2 from combustion, but it eliminates NOx emissions and also greatly reduces emissions of SO2 and other acid gases as well. And potentially you get lower gas volumes as well, which could make CCS cheaper in the future. Currently, it's only applied to smaller furnaces with producing higher value products. That's where the economics stack up for it, because as furnaces get smaller, gas-fired furnaces become less and less efficient. So it can pay off to use electric furnaces on the smallest melt, sort of around 80 tons a day, I think is around maximum for tableware. But it is applicable to furnaces sort of up to around 300 tons a day, we think. And we see that some of the container glass sites may switch to all electric melting in the future. The hybrid furnace technology, what we mean by this, we use hybrid furnaces at the moment in that we have air-fueled natural gas furnaces with electric boost, but hybrid furnaces we're talking about are those that are capable of using between 20 to 80% electricity, and that will be combined with Oxyfuel combustion, initially with natural gas, but then hopefully in the future switching from natural gas to hydrogen. You'll have seen in the news about the FEVE furnace of the future, which will hopefully successfully get funding and be built in Germany over the next few years, and that's going to demonstrate a hybrid melter which is able to use up to 80% electricity, and hopefully that will pave the way for installation of hybrid furnaces throughout the UK, providing it's successfully demonstrated. We expect hopefully to see results by 2024. So within the model, we're assuming that by 2027, manufacturers would have the confidence to install hybrid furnaces, and that would future-proof the furnace, because it will allow you to start off using a small amount of electricity, and then sort of build up to 80% as electricity costs hopefully reduce. Hydrogen is something that we initially discounted in the 2015 roadmap process due to the flame luminosity. But now with the planned sort of net zero clusters in the UK and production of hydrogen from sort of renewables, there's a sort of lot of interest in hydrogen now. So there's the Glass Futures fuel switching project, which is looking at it, but there's also separate projects in Holland, Germany and France looking at hydrogen. And we hear that the initial trials from that are quite promising. So we expect to see hydrogen in the net zero clusters by 2026. So there's a few of our members that are going to be able to take advantage of that when it's available. And then hopefully CCC are predicting that outside of the clusters, it'll start to become available at 2036. I'm going on to the Glass Futures fuel switching project. They're evaluating hydrogen, electric melting, hybrid furnaces and biofuels, but also as part of that, they'll be working with our members to put together an economic cost model to look at the price of switching between the various fuels. And hopefully that work will be available early next year. Next slide, please. So on to process emissions. We mentioned process emissions earlier. So cullet not only saves energy, but it also reduces emissions of processed CO2 because it doesn't contain any carbonates. So for every tonne of cullet that you do use, you save approximately 200 kilograms of CO2, and you also get a saving of 1.2 tonnes of raw materials. For flat glass, we've aligned the strategy with work from Glass for Europe, which assumes that flat glass will be able to reach around 40% cullet by 2050. And for container glass, we've looked at collection rates. So we've assumed that we reach a 95 collection rate and looked at what's placed on the market. But assuming that we still make the same product mix, we will have a shortage of flint cullet still for container glass manufacture. Another thing that's being looked into at the moment in terms of process emissions is use of calcined raw materials and alternative raw materials. So calcined raw materials are carbonate materials that have been heated to drive off the CO2. So to be net zero, that would have to be carried out in conjunction with CCS. So that would be quite a costly material, I'd imagine. But it is an option for glass manufacture. And there's also carbonate-free alternative raw materials that we're looking into at the moment, as well as other raw materials that would have the potential to reduce the melting temperatures as well, which would save energy in the process. And finally, carbon capture storage. It's not something that's viable at the moment for the glass sector. Currently, the sort of acid gases within the mix in particular, they don't, not really compatible with the current amine scrubbing technologies, but we know that there's some work on that ongoing, and we hope that by late 2030s, carbon capture storage will be available for the glass sector to use. It'll be easier for those next to the net zero clusters because they'll have the infrastructure in there for transport of CO2 and storage. But for the dispersed sites, you can see it's still an option, but you'd probably need the CO2 to be tankered off-site for storage. Within the model, we've only assumed that CCS is going to be viable for the larger furnaces. So the flat glass furnaces, which are only going to be on 40% cullet, but also some of the larger flint container furnaces as well, which are going to be on a lower cullet ratio. So that was probably going to make carbon capture storage a more cost-effective option. Next slide, please. So finally, this is the chart that you'll see in both the summary report and and the main report. It's one of the main outputs of the model. So what this is showing, it's showing the two sort of dark blue bars on the left-hand side. They're the emissions in 2002 and 2018. So what we've done there, we have sort of a relative emission. So we've expressed it in tonnes of CO2 per tonne of packed product. So this is for all the glass sectors combined here. We haven't published any results for individual sectors. So what we can see here that in 2018, that since 2002, the emissions have reduced by around 23% relative to 2018. And we think this is mainly due to grid decarbonisation, increased use of cullet and energy efficiency measures within the sector. So for combustion emissions, we eliminate all the CO2 from the combustion emissions in 2018, and this is through fuel switching to electricity and fuel switching to hydrogen as well. You can see from there that we're going to be heavily dependent on electricity, so that's why it's so important now that the grid infrastructure is upgraded and we get those site connections as soon as possible to allow us to sort of progress to net zero and implement these technologies. So here we mainly have some electric furnaces, and the remaining furnaces being hybrid furnaces. And we assume that by 2050, any hybrid furnaces that were using natural gas will have been converted to use hydrogen. And so for process emissions, increased cullet use reduces emissions by around 3%. This is due to, there won't be the availability of cullet for flat glass. Continuous fibre doesn't use cullet, and for container glass, we're still going to be short of flint glass cullet. There's also an effect due to, we've assumed some increases in pack rate as well, so there's going to be less availability of internal cullet for sites to use as well. We also assume a little bit of use of calcined raw materials or alternative raw materials, assuming that there's going to be sort of successful demonstration of those through projects that are ongoing at the moment. And also, as I mentioned before, some carbon capture storage as well. And the final piece here is grid decarbonisation. Decarbonisation of the grid is going to help us to go beyond net zero. So that's in part is due to reduction of the CO2 from electricity that was used in 2018, but also we're going to be using a great deal more electricity as well. So that results in nearly 0.2 tonnes of CO2 per tonne of glass packed in negative emissions from electricity use. Okay, I think that's me done now. So I think Paul, you wanted to say an extra?
Yeah, I think just very quickly, how you guys can help. We welcome stakeholder meetings to discuss the challenges and barriers and policy recommendations, especially with government departments, and we will be reaching out to them departments. And then, consider, we've got many different stakeholders on board here, so consider how you can help address some of the barriers that the glass industry face. And obviously, please do get in touch with us. And I did mention before, but get involved if you are interested, especially from brand owner point of view in terms of container. Get involved with the closed glass loop British Glass work if you're not already. Because that's where we're looking at a lot of the recycling issues and DRS issues and colour change issues, etc. So straight on to Q&A. Meg, if you want to pull out some of the questions.
Yeah, definitely. So we've had a couple of questions through from Rob that Dave's already answered mostly around lightweighting and DRS. Have you got anything you want to follow up on from those, Rob?
No, that's all pretty clear. The reason for the question on lightweighting was because we've been doing a lot of work on our own carbon footprint, and we know that packaging in general accounts for about 8% of our carbon footprint. And there's a lot of thought within the co-op that one of the big ways to reduce the carbon emissions from packaging is to lightweight glass. So it was interesting that it doesn't feature at all in your plan.
Sorry,
it's not.
I'll come in there.
Sorry, go on.
Yeah, what we've looked at here really is just really the scope 1 and 2 emissions. So we haven't looked at any sort of the transport, which I think is probably what you're covering there. So we realise, I think like Dave mentioned, there's been quite a lot done in this, but I suppose the co-op you'll be looking at, the transport is probably one of your big CO2 impacts. So obviously lightweighting will help with that as well. So really this has primarily looked at scope 1 and 2. There is a section in, I can't remember which one it is now, section 5, I think, on how glass can sort of reduce the CO2 impact of other sectors.
I think a further comment, Paul, is about as we stare further into the future. This is a 30-year plan, and as Mark already outlined, longer term, we look to a decarbonised grid, we look to electric transport, hydrogen transport, whatever. The carbon footprint of transportation and therefore the weight element of that equation will change quite significantly as this progresses. So we're not keen to work on something that maybe compromises the integrity and usefulness of the product at this stage to take it beyond where it ought to be, when that may be factored out significantly as the whole sort of grid is decarbonised and our transport carbon impact becomes less of a piece in that equation. So we're not ignoring it by any means, but we're trying to rationalise where it fits in the scheme of things. And there are certainly more major problems that we have to address in the sort of opening of this, as Mark outlined. The direct fuel infrastructure to get from where we are to where we need to be needs a lot of technology solving, needs a lot of buy-in, needs a lot of government support. And these are the major things that we want to get off the ground. We see some of the other things like lightweighting as part of that equation, but as we've already done a lot of that, we felt with the consideration of it, we didn't want to reopen that as a major argument at the outset. I think it's something that will emerge and our understanding will evolve as the rest of the thing progresses.
Okay, thank you. And then on the DRS point, do you think it is realistic that the MRFs will stop collecting non-beverage container glass?
It's not stop. The plan is not to. The deposit is only levied on certain categories, and foodstuff is not part of that. So our issue and concern is that as part of the recovery chain, local authorities are not incentivised to go that extra mile to separate, the dross that's left all mixed together and broken. There's no value in doing it. So to be fair, it is the highest quality material we have. As already outlined in the presentations, our problem in the UK particularly is the discrepancy between the consumption and the manufacture. We manufacture more flint and we consume more green. The flint becomes lost in foodstuff. Most foodstuff's in flint glass. So it's a big part currently of what we recover to be able to melt whiskey bottles and things which we export. But that will be compromised under the normal plans for a DRS. This is part of our major gripe here. The plan is built around the need of other materials and glass is roped into it. Had it been built around glass and our needs, we could have factored that in from the start, but it's not. It's really built around the needs of solving the plastic issue, and we're caught in the trap. It's not that we're against DRS, we're against the DRS is badly thought out and negatively impacts the recovery of glass. Our ambition always remains to recover every piece of glass we place on the market, but we've got to have a viable infrastructure that allows us to do that. And currently, DRS would need to change quite significantly to allow that to happen. One of the things we're looking at to aid that is a digital DRS, which negates the need for a physical return centre and puts a better infrastructure together to allow us to map and trace things, and therefore itemise where within the recovery chain there are issues and focus on those issues to get the best out of it. So we are open to these things. We just don't want Delta ham that ultimately services the material needs of competitive materials and leaves glass in a compromised position.
Great, thanks, Dave. I think we've got time for just a couple more questions. So I've got one that I think will be for you, Mark. In your modelling, what percentage of increased cullet use have you assumed for the reduction in process emissions?
Okay, for flat glass, we've assumed around sort of that they reach around sort of 39–40% cullet, and that's the best information we've got from Glass for Europe. Looked into this in a bit more detail and sort of looked at how much glass would be available. Obviously, we're hopeful that we'll be able to go beyond that, and we're sort of still working on that at the moment, but that's the best figure we had for the model as it stands.
I think just to add to that, Mark, there's a lot of work going on currently with policymakers around specification of new buildings, such that instead of what we had maybe 20 years ago when we first embarked with RAP on the journey to try and recover glass from demolition sites, buildings being demolished, the reticence there was of the contractor to be penalised by the project owner for not delivering on time, therefore easy to blow a building up and stamp the glass into the ground. I think there's a big will at the moment to change policy such that demolition will be financially viable by specifying buildings to have the glass stripped out before they're demolished. And that would change that factor quite significantly. But it's early days in that equation and lots of people remain to be convinced. But it's part of our motivation and it's something that would make a drastic difference to the numbers.
Great, thanks, Dave. I think that links into this question that we've just had here about engaging with British Glass, about getting glass from demolition back into cullet, which is something we've looked at before. So Paul's just popped his email in the chat box there for you to get in touch with him on that topic. And then we'll take the last question I've got is around what role do you see on-site generation and optimization with storage playing in our road to net zero, sort of meaning solar and wind power and battery storage?
I'll start, then Mark can add onto it. But I think, yeah, I mean, we have looked at this, but the amount of electricity that we need is where, I mean, I think Mark's done some calculations, so Mark will probably have the exact details, but we need too much electricity to be able to generate it ourselves. We can use it to a certain extent to sort of back up, but with a furnace, we need uninterruptible supply as well. And, potentially with that, it could never be used off grid. We could never go off grid like some domestic properties can. I'll pass over to Mark. I think you've probably got some more precise detail.
No, I think you covered it, Paul. I think, we potentially there is a role for some sort of backup, electricity backup, but in terms of on-site generation, waste heat recovery is a good option. But when we start to talk about solar power, I think we need about 60 football pitches full of panels to be able to run a furnace. So yeah, there is one site with battery storage, but I guess it's how the economics stack up at the end of the day, and if that's going to be an advantage to them in terms of grid balancing potentially or something.
Great. I think we're about at time there. So if anybody's got any further questions, if you just want to drop them over to any of the email addresses that are listed in the chat or to info@brickglass.co.uk. Have you got anything to add to the end, Dave or Paul?
No, other than say thank you all for participating today. I hope it all came over as a very positive experience, that you will join with us. It says there on the slide, how can you help? I think we've made that abundantly obvious today. We want to connect with you. We want your ideas, your concerns. We want to be able to answer your questions and work with you to solve some of those things. So please do be in touch with us. As Meg says, the email address is there at the bottom. So please get involved with all of our initiatives from closed to glass loop right through to fully decarbonising everything that we do within glass manufacture. It's a journey that we can't embark on alone, and we need your support to deliver it, and we're absolutely confident we can do that. Thank you everyone for your time today.